Okay, so a little bit more about angles. First thing is adjacent angles. So those are two angles that share a side. So they have a common side. Common vertex. But no common interior points. But no common interiors. So in this first one, we would say that angle 1 is adjacent to angle 3. So that answers the question, but we also know that angle 1 and angle 2 are adjacent, but 2 and 3 are not adjacent because they don't have enough in common. In the second example, name the angle adjacent to ABD. So ABD is this angle right here. So we know that it would be adjacent to this angle right here. And so we would say angle ABD is adjacent to DBC. Remember that when you name angles, we can't say angle B here because it's the vertex to too many angles, but we do say DBC and B is in the middle because it's the vertex. Complementary angles are angles that sum to 100, they sum to 90. So together they form a right angle. So we know that 28 plus x equals 90. So we know that angle J would have to be 62 degrees. So if they're complementary and they add to 90, if we've got a right angle, we know that they would be complementary. So in this one, we've got a 90-degree angle here. BFD is 90 degrees. So we know that the two angles that make it up are CFB and CFD. Supplementary angles are angles that sum to 180. Which means when they're added together, they equal 180. They make a straight angle together. So if F and G are supplementary, find the measure of angle F. So 132 plus x equals 180. Subtract 132 from both sides, and we find that x is 48 degrees, which means that angle F is 48. In this next one, we don't have to solve for anything, but we're just trying to find two pairs of supplementary angles. So there's more than two in this picture, so we're just looking for two angles that together make a line. So we could say DEF and FEH, but we could also say DEG and GEH. We could also say FEH and HEG. We can also say DEG and DEF. So you've got lots of options there. There's a lot of answers. You don't have to just pick one. All right, linear pair. This is a little bit of a lengthy definition, but it's a pair of angles whose non-common sides are opposite rays. So basically, they equal 180 degrees. They're supplementary. So very similar to supplementary angles. So in this first example, the measure of angle 2 would be whatever we need added to 138. That gives me 180. So we could say 138 plus angle 2 equals 180. And we find that angle 2 is 42 degrees. In the next one, name all the linear pairs. It's very similar to finding the supplementary angles. So we know that 5 and 6 are linear pairs. We know that 5 and 7 are linear pairs. We know that 7 and 8 are linear pairs. And we know that 8 and 6 are linear pairs because together they make a straight line. Find the value of x in each angle if SOP is 5x and ROQ is 4x plus 10. So we're going to practice solving on the back, so we're not going to solve this one completely, but we will set up the equation. I'm sorry, I put that in the wrong spot. We're going to come back and solve that one after we talk about vertical angles. In the next one, we're also going to come back and do that one. Sorry, I got my notes out of order. All right, vertical angles, real quick, are two non-adjacent, which means they're not beside each other. So they're two non-adjacent angles formed by intersecting lines. The only thing they have in common is their vertex. So vertical and vertex is the only thing they have in common. So name two pairs of vertical angles. They're across from each other. So 1 and 2 are vertical, and angle 3 and angle 4. In the next one, name the angle vertical with VZY. So the only thing they can have in common is the vertex. So VZY would be vertical to XZW. These vertical angles are congruent. So using that information, we can go back up here and solve. So let's look over here. So 5x and 4x plus 10 are vertical, which means they're equal to each other, which means if we solve, x is 10. Which means that we've got 50 and we've got 50. If we use what we know about linear pairs, we know that this angle, SOP and POQ, are supplementary. They are a linear pair. So if this piece is 50, we know that this piece is 130. And then we can use the same information, so 50 and 130 give me a supplementary angle. We also could have seen that this angle and this angle are vertical, so they're both 130. If we look here, we've got 72 and 41. So using what we know about vertical pairs, if they are formed by two intersecting lines, 72 is made up of these two pieces, so the rest of those intersecting lines are here, so that means that angle 1 is 72 degrees, which means that angle 3 is 41 degrees. And then using what we know about linear pairs or supplementary angles, we know that angle 1, angle 4, and angle 3 make 180. We know that angle 4, angle 1, and 41 degrees make 180. And so as long as we only have one thing missing, we can find those missing angles. So 180 minus 72 minus 41 gives me 67. And we know that angle 4 and angle 2 are vertical, so we don't have to do under other algebra. We can just use that vertical angle relationship. Big picture, linear pairs are supplementary. Vertical angles are congruent. So use the following picture to set up an equation. Name the angle relationship you use. So up until this point, really the two that we're going to look at are linear pair or vertical. And so all we're going to do is set up the equation we're not going to solve. So in A, find x and the measure of angle CBD if the measure of angle ABF is 5x minus 2. So ABF and ABC is 10x minus 10. So those two together, are they linear pairs or are they congruent? Since they make a line, they're linear pairs, which means they're supplementary, so which means we're going to have 5x minus 2 plus 10x minus 10 equals 180. You would solve them, find x, and then plug it in for CBD. B, find x and the measure of angle ABC if ABF is 8x plus 13 and CBD is 15x minus 8. So the only two pieces of information we have, they're opposite of each other. They are vertical angles. Vertical angles are congruent, so we would set both of those equal to each other. Solve for x, and then we would plug it back in for either one of those. To find ABC, we would also have to use a linear pair relationship because they don't have any other connection to angle ABC. C, if BD bisects CBE, so we've got that bisect again, which means we've got two equal pieces. And CBD is 6x minus 3. And CBE, so this whole thing is 10x plus 8. Find x in the measure of angle ABE. So we'll go back to everything we know about angles. Little plus little equals big. So if this angle is 6x minus 3, I also know that this angle would be 6x minus 3. I don't really have anywhere else to start, so we'll just start there. And then we'll solve it, and then to figure out ABE, we're going to have to figure out the relationship between this angle that we know and this angle. Well, together they make a line. And then we would have to piece it together one more time. So at that point, we would have EBF, and then we would have to piece together that ABD is a straight angle, so we'd have 6x minus 3, whatever that equaled, whatever this equaled, added together, and whatever was left to get 180. You could also use your vertical angle relationship. So 6x minus 3 is here, so ABF would be here. D, the measure of angle 1 is 11x minus 6. Make sure you're drawing it in your picture. 2 is 8x plus 9, and 3 is 17x minus 3. All three of those together make a straight angle ABC, so we'll add all of them up, set them equal to 180, solve for x. Again, I'm just setting it up. I want you to continue solving it, practice those solving equation skills. E, we've got DBC to find. ABF was 8x plus 7. CBF, so this whole thing was 153 minus 4x. So those two together form a linear pair. Which means that them together equal 180. And then you would use your relationship to the rest. So DBC is a vertical angle to ABF. And then last, to find x in the measure of angle AFE if AFB is 3x plus 5 and DFE is 40 minus 2x. So we see they're kind of opposite each other. They are vertical angles. Vertical angles are congruent, so we'll set them equal to each other. Solve for x and then see what kind of relationship they have with AFE. Last thing we're going to talk about is perpendicular lines, rays or segments intersect to form right angles. So in example 5, we're going to find x so that KO is perpendicular to HM. So this symbol right here means perpendicular. If KO is perpendicular to HM, that means that all of these angles are right angles. I'll do them in 2 different colors so we can see them all. So if we're finding x and this angle is a 90-degree angle, we would say 9x plus 3x plus 6 equals 90. And the very last example, we've got FC, which is perpendicular to FD. The measure of angle AFB is 2x plus 9. BFC is 6x plus 1. And AFE is 263 minus 8y. So we've got 2 different variables. We've got a lot of information going on. So in order to solve for those, if I know that CFD is 90 degrees, that's half of a supplementary angle, it's half of a linear pair, I know that this other side is also 90 degrees. So to solve for x, we'll have 6x plus 1 plus 2x plus 9 equals 90. Little plus little equals big. We'll go ahead and solve this one. We haven't solved any of the others. I think we can afford to. So we find that x is 10. When we plug that 10 in, we get 29 degrees here and 61 degrees here. At 90 degrees here. If we know that AFB is 29, its vertical angle is also 29 degrees. And there's 2 ways to think about this one. Actually, there's a lot of ways to think about this one. We know that if we go full circle, all of them together have to be 360. We also know that AFE is a linear pair with AFB. So we could do 29 plus 263 minus 8y equals 180. We could also do 263 minus 8y plus 29 on that side and get 180. Either way, it'll give you the same answer. So we'll solve one more equation. Combine like terms and solve. And we should find that y is 14. So that one's a little bit tricky. Make sure you check back later to make sure that you have solved the other equations correctly. Let me know if you have any questions.